SAT 22 for week 16, a student produced response question. Let's take a look. The graph of x squared plus x plus y squared plus y is equal to 199 over 2 in the xy plane. This thing is a circle. What is the length of the circle's radius? And a fairly straightforward question if you know anything about the equation of a circle, and if you don't, I'll teach you. Anyway, how did we do on this question? Well, the answers were kind of all over the place, ranging from a -10 all the way over to something a little bit bigger than 99.5. The spike here, where 80 people answered it, doesn't tell us what the answer is, but it's a little bit over 9.9875. That was the correct answer. Only 55.6% of people answered it, just a little bit over half. I'm not going to tell you what that answer is. I don't want to spoil it for you. We'll take a look whenever we dive into the solution. So overwhelmingly, people used Desmos, and we're actually going to use Desmos on ours as well as doing the thing by hand. We're not going to be phoning a friend, though. I can be your friend. You can phone me. Anyway, I'm not going to tell you my number. That would be crazy. That would be really creepy. Anyway, so let's see. We thought it was easy, which is a little bit strange. It's funny because only about half of us, just a little bit over half of us, got this thing right, and we still thought it was a pretty medium, just slightly skewed towards the easier side. Well, that's just what they do over there at College Board. Here, let's take a look at the actual solution, shall we? So I mentioned that we needed to know something about the equation of a circle. So I'm going to actually show you how to get it because it's not that hard. I think you can handle it. Equation of a circle. Now, at home, of course, you could just search this thing up and the internet will tell you what the equation of the circle is, but this is going to be a lot more valuable because you'll see where it comes from and you can get it yourself if you need to. It's all based on the Pythagorean theorem. Good old a squared plus b squared is equal to c squared. That's where it all comes from. You might be going, what does that have to do with a circle? Well, here, let me show you, shall I? So circle right there. We need ourselves a center point, and the center point is commonly h comma k, as in the ordered pair, whatever the heck it turns out to be in terms of numbers, we represented symbolically with h and k. And then remember what the circle is just it's just these points that are on the green part here. That is the circle. And I'm just going to pick one of these things at random on the circle. Let's say I pick this one here. It would have x coordinates or xy coordinates as x comma y. That's what I'm going to just call it. So this represents essentially every single point here, just in terms of a variable. Okay. Now, it also has a radius, so I'll throw the radius in here, which is ordinarily commonly referred to as an r. And since we have ourselves a radius that is at a slight slope here, I can turn this thing into a right triangle thusly. I just bring this segment straight down, bring one over here to the, oh, I missed it by just a little bit. Okay, I'll fix that. Okay, and then there's our right triangle. And that is the usefulness of the Pythagorean theorem, is because it allows you to relate the lengths of the sides of a right triangle. We just have to figure this out. We got the hypotenuse. That one's easy. But what about this bottom, this A part, and this B part here? Well, it's actually easier than you might think. What we're going to do is we're going to project these points, deet, down to the x and the y-axis like this. So I'm going to bring this thing straight down here. And this coordinate right there would be h. It's the same thing as the x-coordinate of that point, right? I'd have to move to the right h in order to get right there. Okay, and then likewise, I would have to move x in order to get to this point. So if I trail this one straight down, project it down to the x-axis, this point would be x. And what I want to know is, what is this distance right here along the x-axis, which would correspond to the bottom of this right triangle? It's actually pretty easy. Let's say, for example, this is the number 5, and this is the number, 3. If I wanted to know what the distance between 5 and 3, sure, I could count up the units, or I could just subtract them. It's 5 minus 3, which is equal to 2, so this length is 2. but I don't know it's 5. I don't know this one's 3. We're going to use variables and just do it exactly the same way. We subtract these two. It's x minus h, the big one minus the small one. Now, we don't really know where x is. It could be way over here. So chances are this is not always bigger than that one, and it technically needs absolute value, but we'll ignore that for right now. You'll see why it doesn't matter in a minute. Okay, now I'm just going to do the exact same thing for the y-axis. In order to get to this k point, I have to go up k in order to get there. So I'll project this thing over to the y-axis, that's k. And then in order to get to this point right here, I need to go up y. So I'll project this thing straight across, and that one is y. And then just like I did at the bottom, in order to find that distance, we'll just subtract those two. So, and that one's going to be top minus bottom, so y minus k. And what we will just do is we will just treat this as our A value. It's the bottom of our right triangle, and this one is our B value. It's our vertical part, and just chunk them right into the Pythagorean theorem. What I'm saying is this. A is going to be x minus h, and then we'll square it, plus B is going to be y minus k, and then we'll square it. And then our C here, of course, C is just our radius equals r squared. There you go. It's the Pythagorean theorem. So here, this is what we can do. We can just chunk this into Desmos. We can make some little sliders. We can move some stuff around in order to figure out what the radius is. That's one way to do it, of course. But it is kind of dependent upon knowing the equation of the circle. Some of you, I think, just threw this thing straight into Desmos, because why wouldn't you? X squared plus x, that's y, plus x plus y squared plus y is equal to 199 divided by 2, right? Let me scooch it down just a little bit. Okay, now I think all of you that got 9 point whatever for your answer, chances are what you did is you found these two x-intercepts here. Let me just kind of chunk, put them into the expression list, and maybe just subtracted those two numbers and then divided by 2, thinking that those two numbers represent the endpoints of the diameter. But here, let's take a closer look at this circle. If you look at the bottom half, to my eyes, it looks like the bottom half is not actually half. It's actually a little bit bigger than the top part, the part that's above the x-axis. So that is actually not the diameter. It's actually a little bit smaller than the diameter. So if we subtract those two x coordinates divided by 2, you're going to get something that's a little bit too small. Okay, so something cool about this is that, can you see how Desmos is giving us these little gray points to the left right here, and then this one right there? Those two are actually the maximum and the minimum points, which would correspond to the endpoints of our diameter, as a matter of fact. So we could be pretty much done here if we used these values, not the previous ones. So here, let me pull these ones. I'm going to delete these guys out, and let's get these ones in here. So like, pull that one in there. Pull this one in here. And then the x value of negative 0.5, if I type that in, x is equal to negative 0.5. So my center point is actually on that line someplace. Okay, so you can see it's not actually the origin right there. Anyway, what I really wanted to do is subtract the 9.5 and the negative 10.5. So 9.5, that's the y coordinate of the purple point. That is not 0.5, now it is, minus a negative, double negative. Let's see if that actually works here. And then 10.5, yeah, it sure did. Oh, look at that, it's 20. So 20 is the length of the diameter, and then 20 divided by 2 is 10. Well, look at that. I actually didn't even need the equation of a circle. We were able to get it as long as we realized that the x-intercepts there were not along the diameter. We had to use the kind of freebie points that they gave us. Okay, now here's another thing that we could have done. let's go ahead and type in the generalized form of the equation of the circle, which we just derived here as x minus h, and we'll turn that into a slider momentarily, squared, plus, that's not plus, plus, parentheses y minus k, and then square that guy, and then is equal to our radius squared, and then we will just add in sliders for all of these things. And now all you got to do is just shift some stuff around until you get our black circle right exactly on top of the red circle. It's like a little game, right? And so we kind of already know that this one should be a negative 0.5, right? And then you may have to just kind of shift this one around to see where it's supposed to be. I'm not quite sure just yet, but here, let's shift our radius so we know the radius has got to be bigger. Ooh, this looks nearly dead on. I just need to move this. Oh, perfect, right? So I lucked out and I was able to just use some sliders in order to get those things. And I can see down here at box number 10, clearly the radius was 10. Okay, could we have done this thing by hand? Absolutely. Of course, the whole entire SAT should be able to be taken without a calculator, and this is how you do it. It is based on a technique called completing the square. Now, believe it or not, this is a technique for solving quadratics that's supposed to be in Algebra 1, but I don't think anybody ever teaches it. But you will for sure get it in Algebra 2. So when we're talking about a square, we're really referring to a perfect square trinomial. When it's in factored form, it looks like this. Let's say I have x plus 1 quantity squared. I'm going to represent this thing geometrically. So geometrically, it's going to look like this, where each of these sides is x plus 1. This side is also x plus 1, right? So that whenever I square this one side, same thing as multiplying x plus 1 times x plus 1, I get the area of this thing. And that's what this thing is representing. However, if I were to, let's say, FOIL this thing out, if I FOIL this thing out, it's the same thing as x plus 1 times x plus 1, and x times x for the first time is x squared, and the x squared would look like this. It would be, I'm actually going to erase this and erase this right here. And this little piece is x by x, meaning that the area of that squared is x squared, okay? And then whenever I do my outside, boop, that's 1x, plus my inside, that's another 1x, so plus x. Those two together, 2x, obviously, so 2x. So where are those on our diagram? So right here, this is a 1 times x, which gives me 1x. And then I have 1 up here on the top. Again, this is 1 times x in order to get x. So there's the 2x that's right there, okay? And then you can see pretty clearly, of course, that you have x plus 1 as the side length of this little square. Did you ever use algebra tiles in Algebra 1? Most of the time they're pretty useless, but they're really nice for representing this whole completing the square business. Now, there's one little thing that's left over. It's this little guy that's right there. And this little guy is 1 times 1, which is 1 squared, which is 1. And it's the same thing as the last terms whenever we FOIL this thing. Okay, so now what we basically want to do is, actually here, let's do a little bit of shading on this because that'll make this thing look even cooler. So this x squared came from that guy, and this x together with this x added together in order to get the 2x, and then finally this plus 1 is the extra square that's left over. Okay, now really what you want to do though is you want to work that process backwards. In other words, you have this. You have x squared plus 4x, and you want to figure out what is the constant number, in this case it was 1, that you would have to add to the rest of this quadratic in order to complete the square. Complete the square that's like this, right? We want to turn it into a square of a binomial. Why do we want to do that? Well, so that we can turn this into an x minus h squared plus a y minus k squared for the equation of the circle, okay? So here's the technique. Right now what we have is x squared, which we know is a square, which would be x times x, x squared. And then we have 4x. So 4x would be a rectangle. Its width down here is 4 and its length is x. That matches up with this length of x. Okay, so now what I need to do is I need to turn this picture into something like this diagram. What I have to do is I have to take this rectangle, this 4x rectangle, and I've got to divide it right down the middle so that I could put half of it on the right side of the x squared, and I put the other half of it on top of it. So I'm going to put half of this right here on the right, and I'll put the other half on the top. So if the whole thing is 4x, when I break this thing apart, each piece is going to be a 2x and another 2x, right? So we're basically taking half of this little middle term that's right there, right? So let me redraw what the square would sort of look like in this case. So again, I have my x squared, x times x, x squared. I'm going to put two x's on the right, so this is a 2 times x, so it's 2x. And I'll put two x's on top, so it's a 2 times x, it's a 2x. And then I'm left with a little square. And that little square is the thing that completes the square. And it's pretty easy to figure out what it is because it's just 2. This piece is 2 times 2. This piece is 2. 2 times 2 is 4. I got to add in a little extra 4. When I add in the 4, it completes the square, and the square of a binomial will look like this. It'll be x plus 2 quantity squared. Ta-da! There's your lesson on how to complete the square. Man, you're getting lots of stuff from this one little video, this short video. Okay, so let's see how we're going to apply that to this equation. Well, actually not this one. This one here, right? So general idea here is in order to get these little rectangles that we're going to split apart and put on the sides of our x squared, that comes from taking half of the middle term. So if I take half of that, I get 2. That's going to be a 2x for each one of these sides, like the top piece and the right piece. And then in order to see what the piece is that we have to add to complete the square, that's the same thing as 2 times 2, or 2 squared. It's this number squared, boop, in order to get that form. Okay, so I'm going to start with this x squared plus x, and then I have to add something to complete the square. Here's the technique. You're going to take the understood 1 that is in front of the middle term x. We're going to take half of that. Half of 1 is 1 half. Then I'll square it. I'll get a fourth, and that is the number that we have to add in order to complete that square. Let me bring the rest of the equation down here. So plus y squared plus y is equal to 199 over 2. Now, I've got a problem. I just added 1/4 to the left side of the equation and made it unbalanced. This thing is slightly heavier than that side, so I'm going to compensate by adding a 1/4 over to the right side of the equation. Okay, now I balanced it back out again. So the square that we just completed can be rewritten like this as x plus 1/2. That's the same thing as this number that's right there, and then quantity squared. Right? So just like this one is x plus 1 squared, because it's the same thing as the side length. It's half of this one. It's the little side length of the rectangle. This one was 2, because we took half of that as 2, or put 2 on each one of the sides. It's a little 2 that goes inside of the parentheses, and this one's going to be the 1/2 that goes inside the parentheses. Plus y squared plus y is equal to, don't bother to add these things together. As a matter of fact, let me kind of make a little bit of extra space here. 199 over 2 plus 1/4, and I left a little space because we want to complete the square one more time. And here you can see that they were real nice to us. It's exactly the same pattern as the x's, In other words, it's understood 1 here. I take a half of it. I get 1/2. I square it. I get 1/4. I added 1/4 to the left, which makes it unbalanced. So we have to add a 1/4 to the right-hand side of the equation. I know you're probably thinking right about now, there's no way I'm going to have time to do this on the SAT. You're not wrong, but the assumption is that you already know all this stuff and that you don't have to learn it on the fly or use Desmos. Okay, so rewriting one more time, x plus a half squared plus y plus a half squared in the exact same way that we did it for the x's is equal to, and now watch this crazy business. I'm going to combine these two fractions. 1/4 plus 1/4 is equal to a half. 199 over 2 plus a half. Hey, since these have a common denominator, we can add the tops together, and that's going to make 200 over 2, which is 100. And we're almost done, finally. Because remember, that last number over there is the same thing as, actually, let me keep them the same color, is the r squared. This is r squared. R squared is equal to 100, so r is equal to 10. Yay, we got it by hand. It only took us 45 minutes. Now, in case you're wondering, remember that the center point is the h and the k. Notice that this has minuses inside of the formula. This does not have minuses inside of this formula, which means that the actual center point has the opposite x and y value, negative a half, comma, negative 1/2. And if we go back to Desmos, all of this will be laid out right in front of us. We can see right here on the h, it's negative a half. The k value is also negative a half, and we look at the radius, and it was equal to 10. Hooray! That should do it.